Masterpiece.
So, excuse me, we say science seeks, excuse
Something
me,
ideas tailored to your song and also get weekly rollout plans way before release date. Go to your song
they've
and
started.
then transfer.
They've started. All right. I think the best thing is to mute everyone. So we say that science seeks knowledge that is objective, certain, systematic, provable, and supported by evidence. Science is the one. So one thing you should bear in mind is that when it comes to science, we are talking of something conscious, something certain. It's not something like I think, or let's just believe. We shall know that there is God in heaven. No, it's not that. You must be able to hold this thing for real that okay, this thing is truly working. So that the same thing, if you test the same thing in anywhere all over the world, you will get the same result. You will get the same result. That is what we call science. Okay, we have a question in the chat box. I need you guys to, contribute to that question. So So let's see this. Through a systematic method of observation, formulation of hypothesis, experimentation, we've done this before, organized theory, construction, etc. It further overcomes the limitation of the senses through the use of instruments, diagrams, equations, and formula symbols. However, some have argued that science differs from non-science only in degree. It is pointed out, for example, that common sense has a certain scientific character. It recognizes certain basic laws of nature and acts on their basis. For example, traditional agriculture, which is based mainly on common sense experience, recognizes the laws governing soil fertility. On the other hand, science involves a certain degree of speculation and imagination, especially at the level of formulating hypotheses. You will discover this when you study the next. Okay, in general, science is said to be objective, systematic, and reliable. Being objective means that all those who adopt the same method or procedure can prove or verify the claims or statements which the body of scientific knowledge contains. What science being objective means is that if in Europe they say that a law of science says that anything that goes up must come down, or that is, let's say, the law of inertia in science is when you throw something up, the thing will definitely come down. If you do that in London, it will be the same, you will get the same result. If you do it in Africa here, you will get the same result. If you do it in Asia, in China and the rest of them, you will still get the same result. That is the meaning of objectivity. It is the same. It has exactness of result. It's just like when they say when you peel your yam and you boil it and then you pound it, you get pounded yam. Anywhere you do that in the world is pounded yam, you definitely get. So that is what we mean by objectivity. It's certain, the laws are not, it's not like it is this in this place. When you go to that place, it will be something else. No, that means it is subjective. Something that is subjective is the thing is liable to change based on condition. But when something is objective, it is standard, it is constant, like your exams where you have subjective questions and objective questions. The subjective questions, you are likely going to guess anything and write anything there. You understand? Like when they ask you now what is science, in your own view you may decide to write science as anything because the question is subjective. Anything can be written there. But the objective one, one of them is definitely the correct answers. Sorry, the correct answer rather. So there may be many options there, but because it's objective, there is definitely one answer that is correct there. So I just use that to explain that objectivity and subjectivity. Non-science disciplines, they are subjective, liable to change based on condition. But science discipline or science laws and principles, they are objective. So that is the meaning of science being objective. What of science being systematic? It means that all the various elements in a body of knowledge are locally related and each can be inferred from the other. What science being systematic means is that when you are studying agriculture, you see a bit of medicine there. When you are studying physics, you see a bit of mathematics in it. So they are interrelated. It's a systematic. The formula here may lead to another thing in another field of science. So this interrelationship is what we call systematic in nature. So, for instance, go to the library and get hold of any science textbook. If you turn to the table of contents, you observe that topics are arranged sequentially. Basic topics in biology, such as the cell, its structure, and functions, are discussed before topics like the structure of the kidney, liver, brain, etc. These latter organs are made up of cells. So you need to understand what the cell is before you can understand the structure of the kidney or the liver. Science being reliable. Okay, so before we go to science being reliable, I've also mentioned the issue of sequentiality when we started this class yesterday, where I said that I wish we would just go straight to Module 3 and study Module 3 and Module 4 alone and leave this material. But I know that the way science is arranged, if you jump Module 1, you will not understand the rest. Anything we are doing in Module 3 will look like a joke to you. You will just be wasting your time. So that is why we have to touch Module 1 and 2 the little way we can touch them, even though we will not read them too deeply like that, but we will touch them. The reason why I'm saying that is that basically they don't usually dwell much. Questions don't come out much from this Module 1. But you see, 3 and 4, yes, that is where serious examination questions come from. So we need to dwell on those ones very carefully. But notwithstanding, if we leave this one, you will not understand, because science or topics in science are always sequential. They are arranged sequentially, so that in Module 3 or Module 4, we meet something that will talk about empirical or formal. If you have not known the meaning of formal and empirical from Module 1, you will not know what they are saying then. It will look like a magic. So that is what it means that science is systematic. We have talked about 3 nature of science here again. That science is objective. Please don't forget that objective. Don't forget it. Don't forget that it is science that is objective, while non-science disciplines, they are subjective. That means they are liable to change based on different conditions in different places. But science is constant. That is, science is objective. That is number 1 nature. Number 2 nature is that science is systematic. One topic or one part of a discipline in science or body of knowledge will lead you to another. So that is the systematic nature of science. The last one is that science is reliable. Science is reliable. The science being reliable means that it can enable us to adequately and correctly explain, predict, and control any phenomenon in question. Thus, science differs from non-science in method and in the systematic character of its knowledge. Now, because they've studied, let's say they've studied weather, and through the study of weather, it's been predicted that tomorrow there will be heavy rainfall and even thunderstorm and the rest of them. People can restrict their movement tomorrow. They'll be able to plan like, okay, tomorrow if there will be rain, okay, if it's just a normal rain, let me go out with umbrella. Or if it has been predicted that it's going to be a very wide one, then I better remain at home and not go out, so that I will not be a victim. Science helps us with that, with preciseness. So after all is said and done, the next unit will show us that science has some limitations, and these limitations are defined by the very method science uses to obtain knowledge. That is the scientific method. So, well, we don't expect anything to be 100% perfect in this world we are. So science has its limitations. We will study that in the next unit. But before we go to the next unit, we have some questions here. Non-science disciplines include dash. Give us 3 examples. Yes, let us make use of the chat box now. Non-science disciplines include dash. We've mentioned them. We've mentioned religion, art, and the rest of them. So I'm waiting for you guys. Your concern is how you can rewatch it. I will upload it on YouTube after the class. The only issue we have on Zoom is that we only have 40 minutes. That is the issue. So, non-science discipline. I have a question there. you guys can chat in the chat box here too. Okay, religion, thank you. Religion is part of them. We have mysticism, thank you. Art, metaphysics, you guys have been following, thank you. So the question number 2 says, list 3 characteristics of non-science disciplines. List 3 characteristics of non-science disciplines. Like religion, now they use religion for example when they were talking of non-science discipline. What are 3 things you think non-science? If you know the opposite of objective, systematic, and reliable, you can actually list the ones that, okay, it is subjective, non-verifiable, and oh my goodness, thank you, Oluwa Pelumi, you are hot tonight. That is awesome. Those are the characters of non-science discipline. They are subjective, they can change anytime. Today, one pastor can tell us that God is yellow. Tomorrow, another pastor will say, I've just find out that God is red. That, so you see, they are subjective. Changes today, changes tomorrow, changes next tomorrow, so or the day after tomorrow. Now, they're also non-verifiable. We have always been hearing that God lives above, God is this, God is that, based on what the Bible or the Quran or anything says. We have never seen him. We don't really know the truth. So it's not verifiable. So it's not factual. It's just like a guesswork. Well, if you do this, you are likely going to end up like this. It's just desolation and the rest of them. So thank you so much, Oluwa Polumi. I love your energy tonight. All right, I hope Dora and Big Eva and the rest of them, they are here. Thank you, my class captain Sule Grace. You are also hot tonight. So let's see if we have another question. Or okay, that takes us to the end of this section. So in conclusion to this section, guys, in this unit, you have learned what the nature of science is. Don't forget that the main thing we studied in this unit is aim of science. Aim of science. Well, not only aim of science, we've done other things at the beginning, like the definition of science, how we can group science, the different ways we can view science, and so on and so forth. So the definition, branches, and aims of science were discussed. The final discussion was on the differences between science and non-science disciplines. From these discussions, you will now be able to tell which disciplines qualify to be sciences and what the overall purpose or purposes of sciences are. Like, you guys, like I promised that at the end of every unit, we'll make sure we answer the questions there, because I find out that they like using direct questions from exercises in this material during the exam. Now, a summary of the whole thing we have learned about in this unit or in this part of the material. We've studied that science was defined in terms of a body of knowledge, a method of acquiring knowledge, and an institution. That is ways we can view science. Then science disciplines can be grouped in 2 main ways, and those are formal sciences and natural sciences. For the formal sciences, we have mathematics, anything that has to do with rules, theories, concepts, like mathematics and logic. We have them. And then we have formal sciences. Then we can group empirical sciences. They are also the ones that deal with observation. If you remember what we said about the meaning of empirical last night, we'll talk about observation, observable characters like physics, chemistry, biology, psychology, and the rest of them. Should I say, what will I use now? The specimen you work on in all of those subjects or body of knowledge, they are all visible, they are observable. You can see them, you can feel them, you can touch them. So we'll talk about natural sciences and social sciences according to the class of object or phenomenon they deal with. Natural sciences deal with natural objects, while social sciences deal with society and social institutions. We mentioned that last night. Now, sub-branches of natural sciences are physical sciences such as physics and chemistry, biological sciences such as biology and microbiology, medicine, and the rest of them. And then we have medical sciences rather, like anatomy and surgery. And finally, pharmaceutical surgery sciences that deals with pharmaceutics and pharmacology, medicine, and the rest. Sorry, drugs and the rest of them. Now, social science disciplines include economics and geography. The purpose of science is to enable human beings to explain, predict, and control nature. This is the summary of the aim of science I read about. They said that it's because we want to be able to explain the world that we are seeing around us, the different things we are seeing around us. We want to explain them. We want to know how they came into being, how they develop over time, how they can be operated, and how we can predict their future behavior. That is the aim of science. So, and then why are we doing that? Because we want to take control. We want to be able to control them in the future or against future behaviors. So non-science disciplines are said to be subjective, unverifiable, non-factual, non-systematic, and not quantifiable. Thank you. So, we don't have time in this. We don't have time. Okay, we have an exercise here, and I don't know what the question is. They just say, okay, they are trying to answer the exercise we've done before. In the tutor mark assignment, they say with examples, differentiate between formal and empirical sciences. Yes, let me give two people the chance to speak. With example, tell us the difference between formal and empirical sciences. Yes, with example. I need two people to do that. With example. Okay, I think I muted everyone. Let me try to unmute. Okay, let me just call, I think Abigail was here since the very beginning. So Abigail, give us example or differentiate between formal and empirical sciences, and you give one example each. Is Dacholom here, Abigail? What of Elizabeth, Benedicta? Anybody, unmute yourself. If you're available,
Yes,
unmute
sir.
yourself.
I'm present.
All right, so what's the difference between formal and empirical science? And you can use the example.
Example. Empirical science, formal science has to do with concept, theory, and rules, which is mathematics. And
Okay.
then empirical science has to do with chemistry, physics, and
Why are they empirical? Why do we call them empirical? What character of them made them empirical?
because they can be observed.
Observed.
And
Thank you.
they
That's
can
what I
be
want to hear. Thank you. So okay, another person now. What do you consider to be the aims of science? Justify, okay. I don't know if that is justify or whatever. Okay, justify your decision as fully as you can. What do you think or what do you consider to be the aims of science? Yes, anyone. Please, we have a lot of people here, so somebody should be able to talk as fast as possible. We don't have time. So that is the last question. Now we'll go to the next thing, scientific method. We have a lot to do. So the scientific method, we've started it earlier on. Yes, I'm still waiting for the answer to that last question. What do you consider to be the aim of science? That was the last thing I said in that unit. So I believe you guys should know it. What is the aim of science? Nkechi, are you there? Let me allow people to unmute themselves. So I think you can unmute yourself now and talk if you have something to say. Talabi Esther, where is
No,
Grace?
sir.
All right, okay. We are with you.
Yes.
I believe that the objective of science is to provide solutions to solve problems. Because first thing, from the scientific procedure you talk about or sequence, a scientist needs to identify a problem first. Then he will think about possible solutions to that problem by carrying out experiments. Eventually, he came up with a theory. And this theory, if proven beyond reasonable doubt, will now become a law. So the main aim of science is to find solutions to problems and get the facts that cannot be proven wrong.
Thank you. You have your own valid point, your own view, but based on the material, what they are likely going to expect you to give in the exam is that the main aim of science is that we want to study the world around us to know how things came to being, how things that we are seeing around us, how they came into being, how they develop over time. You understand? How they operate, and then to be able to predict what will happen to them in the future so that we can take control. That is the aim of science. Thank you. Your point is also valid, but you know now and verbatim of a thing. If they ask you in the exam, that's what they're expecting. So, oh goodness. This one is jumping and jumping and jumping, and I don't know where it's going. So let's go to scientific method, guys. Scientific method is not something we should waste time on, because from the foundations we've laid in the previous unit, it's something we all know by now what scientific method is. Okay. I think I've read this at the beginning of the class. We thought we were supposed to start from this place. So let's see. Scientific method of acquiring knowledge. Superficially, science is a collection of facts, a body of knowledge. Now, that describe and explain the workings of nature. That's the main concern of science. Like our brother just said now, we are dealing with this nature we are seeing around us. What is really happening? Problems here, how do we solve them? Although these facts are interesting, even fascinating, they are not the essence of science. Rather, the excitement of science lies in the intriguing observation and the carefully designed experiment that scientists have devised to help us learn about nature. Now, the important thing here is the process of science, not just knowing the fact, but appreciating how scientists discovered and continue to discover those facts. So, if you enjoy science more, if you are not just interested in them saying that there is a law called law of inertia, when you throw something up, it will come down. If you are much more interested in how did they come about that law, you will see that science will become more interesting to you. If you are not just interested in the results they are giving us, or in the principles they are giving us to follow to get or arrive at something, if you are much more interested in how did they come about those principles, what happened, who sat down, what were they studying before they came up with the solution, how did that man sat under a mango tree and saw that the mangoes were falling freely, and he noticed that there must be something drawing them to the earth, and he came up with the law of inertia, or the law of gravity, the law of gravity that says that anything that goes up must come down. So if you are more interested in the details of how they came about those facts, not the facts alone, then science will become more interesting. Now, the process is characterized by a sequence of steps, which we call scientific method, which enables scientists to approach objective truth as closely as possible. Now, taken singly, most of the steps are commonplace procedures carried out by people on a daily basis. Taken together, they amount to one of the powerful tools man has devised to know and control nature. Now, the nature of science, okay, we have a reference to read, but that's leave that. So what are the scientific methods? It starts from something we call observation. So step one in the scientific method is observe. Please, this is where you need to digest the steps one by one, because exam is funny. They may ask you that what is the third step in the scientific method? You are not just here to know the scientific method. You must know the steps that must be followed one by one by one by one to arrive at the scientific method. So that when you are asked that, what is the fourth thing you do in the scientific method, you will know it, not that you'll be cracking your brain. So we need to know that every scientific invention or whatever we do in science today begins with what we call observation, since the method that science uses to come up with ideas is through scientific method. And this scientific method is made up of several steps. The first one is observation. Knowledge comes from noticing resemblances and recurrences in events that happen around us. Observation is the first step of the scientific method. That is the way they like asking it. Dash is the first step, dash is the second step, or this is the third step, or sorry, this is the dash step of the scientific methods. Observation is the first one. Thus, anything that cannot be observed cannot be investigated by science. This means that if observation is the first thing science take into consideration to come up with scientific theories, it means that we cannot use scientific method to deal with anything we cannot observe. That is why science cannot study God, because we can't look at God like this and start observing him. Is it tall? Is it short? No. So that is that on that. So observation, you are all scientists because on daily basis you observe things. You see things, but the only thing is that the way we do it now is because of amebo, you used to go and observe things so that you carry you carry news, amebo news to your friends and family at home. You are not really observing things to come up with solution or to come up with more intriguing conclusions on them. So, for example, a young student observed that maize grains, which were placed in a wet container inside a dark cupboard, germinated, but that the leaves were pale yellow instead of the normal green color of leaves. So when that happened, the student will now come up with different questions. Why was why did we have a green leaf? Why did we have a pale leaf, which is a yellowish type of leaf? Why is it not green? Because normally when you plant maize, you are expecting a green leaf. When it starts germinating, questions will start coming up by observation. Now, scientific observation can be both direct and indirect. Please, let's note that we have two forms of observation, direct and indirect. Direct observations are made with the aid of the senses, just as our hypothetical student observed the maize grains with his eyes. So the direct types of observation is the one that is involving your senses, like your sense organs. We mentioned the 5 of them in the class last night. So when you use your eyes to observe something, you feel something with your skin, or your palm, or whatever. When you hear something, the sound of something, and you're observing it, they are all direct. Somebody is raising hand. You see, this is the thing. This is why I hate this Zoom. 40 minutes. It's almost done. If you raise your hand, if you have something to say, quickly say it before we continue. We don't really have time. Okay, let's continue. So observation can be in two forms: direct, the ones we use our senses to observe, and then the indirect one. Okay, let's move on. Indirect observation are performed with the aid of instrument. Don't forget that in the first unit, we talk about scientific instrument that science has come up with to help us measure behavior of nature or things around us, or deal with them in a more complex way. So when we use instruments, we are using indirect method of observation, like when you use a telescope or whatever to observe things, or a microscopic tool to observe bacteria and the rest of them. So atomic nuclear and magnetism, for example, cannot be perceived directly through our sense organs, but their effect can be observed with instruments. What other things do you think can be observed indirectly? Yes, can we give an example of things? We don't really have this time. Are you sure we'll not go back to YouTube after this, their fourth? Or probably we'll start another one the way we normally do it. Once this one finishes, we'll start another Zoom meeting instantly. Which one do you guys prefer? It's YouTube that is having a common or a general issue with life or whatever this evening. So I think we'll likely restart another section here. Are you guys in support of that? Yes. I'm not getting responses. I hope I have people with me here. I didn't mute everyone now. You guys can talk.
Chance.
Somebody said we should try YouTube again.
Instrument.
Okay, no problem. Maybe we'll try it after this. If it doesn't work, then we'll just forsake it tonight. So observations can also be classified into spontaneous or passive observation, which are unexpected, like an animal that is just doing its own thing or its own thing, and you are there busy observing. Okay, so this is how this animal eats. This is how this animal mates. This is how this animal, because you are watching that they don't know. That is spontaneous or passive. Then we have induced or active observation, which are deliberately look out for. For instance, when you decide to check the habit of rats by caging some rats and then start feeding them, start seeing their behavior day to day, see the way they do in the night, in the daytime, when you put light, how do they behave in the night? How do they like the dark? When you start doing that, you catch them. You intentionally want to do that experiment. So observing them in that format is induced or active observation. But when the animal or the thing you want to observe is just doing its own thing, but you are there observing, that is spontaneous or passive observation. So under that now, under observation, we mentioned two important things. The observation can be direct or indirect. The direct one is one we can perceive through our senses, while the indirect one, use of instrument. Also, observation can come into from classes of observation, two classes. One is spontaneous or passive. The second one is induced or active. And you know the meaning of the two of them now. Now, effective spontaneous observation involves firstly noticing some object or event. The thing noticed will only have meaning if the mind of the observer, either consciously or unconsciously, relates to it some relevant knowledge or past experience. It can also be important if the observer in the process of thinking over it arrives at some hypothesis. So effective spontaneous observation involves firstly noticing some object or event. Now, from our hypothetical event or example, the one given above, the student noticed that the pale yellow color of the leaves of the maize grains was different from the normal green color of maize grains. He thus related what he observed with his previous knowledge. Why was he concerned that the leaves were pale yellow? Why? Why doesn't he just think that that is the normal thing that was supposed to happen? It's because he already had the knowledge that the leaves of maize plants usually used to be what? Green. That's what they're saying, that when you are doing spontaneous observation, you have to relate it involves some degree of your past experience, what you already know, the knowledge you have. That is what you measure things with. You now compare things with and see that, okay, something is really happening. Something is really happening. What they are saying is that if you are going on the road now and you see a dog that is walking on two, what's it called? On the feet. You know, they normally go on their four, whatever. But now you see one walking on two and walking normally, standing upright. Like that one will call your attention. The reason why it's going to look awesome to you and you want to observe what is really happening. Is this thing drunk, or has it taken something weird? The reason is that you know already that dogs go on 4 feet. So something is really wrong with this one. That's what they're saying, that your knowledge is employed, your past knowledge is employed when it comes to observation in spontaneous or the passive. I think that should be the passive method. So powers of observation can be developed by cultivating the habit of watching things with an active, inquiring mind. It is no exaggeration to say that well-developed habits of observation are more important in scientific research or even in daily living than a large accumulation of academic learning. Of course, you will know this better when you want to do your final year project and you need to go for research. So it will become clearer. Now, correct observation is a most difficult act acquired only after long experience and many errors. The difficulty lies largely in unsuspected bias. People forever see what they want to see or what they think they ought to see. It is extremely hard to rid oneself of such unconscious prejudice and to see just what is actually there, no more and no less. This is the reason why a scientific observation must be repeatable. Yes, when you are observing something, you know, science is objective. Anything you get as a result, somebody should be able to repeat it and still get the same result. That is the meaning of objectivity. And that is what makes it science. So the way you observe something with intention, someone else or anyone else should be able to observe that same thing and still come up with the same result. That is when your observation become, acceptable, or should we use the word standard? Now, science does not take any observation at face value. several scientists must be able to repeat that observation independently and report. Okay, must be able to repeat that observation independently. That means different scientists, different people should be able to repeat that observation you observed and report the same thing that you reported when you did your own observation. That is what makes it a valuable asset to science. So, and that is just the nature of science. And that should train your mind on how to observe from today. When you start seeing things, observe them with intent. Don't just be looking at things for you to gather stories that touches the heart. Learn to observe things. That is the first step in scientific method. The scientific method is made up of several steps. The first one is observation. And under observation, we'll look at direct and indirect observation. And we'll also look at the spontaneous or passive observation, the one that the thing you're observing is actually not aware. Why we have the active one or the induced one. The active observation is also called the induced observation. Those are things they ask in the exam. They will not really ask you the direct thing. They will just say the induced observation is also known as that. So you see, it's also known as the passive, the active, while the spontaneous is known as the passive. Those are classes of observation. And then we'll talk about the observation must be repeatable. That means when you observe something and different types of scientists or different type of people observe the same thing, they must get the same result or bring the same report about that thing. That is what makes your observation valuable to science. This meeting will end now. We have less than 1 minute. So guys, I will try YouTube again. You guys should just go to my YouTube channel and wait. Once I start live, try to join. If it works well, fine. If it doesn't work well, we'll still come back to Zoom. Thank you.